What's up, everyone? Welcome back. Patrick here. Moving on to the next example, dealing with polynomial functions in advanced functions. So what we have to do is find the symmetry of these functions, right? Are they going to be odd, even, or neither? And starting off with part A, we got f of x equals x cubed minus 5x plus 3. So notice that this is a cubic function here. An expanded one, notice that b and c, they are actually factored ones, right? So I feel like part A is going to be a little bit easier. Now, remember, if f of negative x is going to equal f of x, then the function is even. And then if f of negative x is going to equal negative f of x, then the function is going to be odd. And then if it's neither of these, then the function is going to be neither. So first step always, let's find what f of negative x is going to be. So what we would do is we'd plug in negative x into the different x values. Now negative x to the power of an odd exponent is always going to be negative x to that same exponent, like that, because there's like a negative 1 here, right? Negative 1 to the power 3 is negative 1. X to the power 3 is x to the power 3, right? If you had negative x to the power of an even exponent, it would end up just being positive x to that even exponent. But if this is odd, you'd end up with negative x to the power of that odd exponent, right? So this would be negative x to the power of 3. Negative 5 times negative x gives us positive 5x, and then that is positive 3. So this here is what f of negative x is equal to, the simplified function. Now, first check we do is f of negative x equal to the original function, f of x, right here. Well, is it? No, it's not, right? We got x cubed minus 5x plus 3. Here we got negative x cubed plus 5x plus 3. So these are definitely not the same polynomials. And so just from that alone, we know that the function for sure is not even. Okay, so the next check that we have to do is check if this f of negative x is going to equal negative f of x. So the next function we have to find is negative f of x. And all you do in that particular case is you put a negative in front of the entire function that you're dealing with. Well, distribute that negative into all the expressions, and we basically end up with that right here. So that's the simplified function for negative f of x. That's a simplified expression. So let's do a check. Does f of negative x, this, equal negative f of x, this here in red? Well, notice it almost does. Negative x cubed, 5x, 5x, but it's the constant that's different. So 3, negative 3, right? And that's a difference right there. And so they're not the same, and so that we know that this function is not odd. And so it's not even, it's not odd. The function in part A, as a result, is neither. Now moving on to part B, this one's going to be a little bit more intense because this polynomial here is in factored form. Whenever you're given polynomials in factored form and you're dealing with f of negative x and negative f of x, it's a lot tougher of an algebraic process. And I went through examples like this in the same section, so I'm assuming you've watched those examples before watching this one. So in this particular video, we might go through it a little bit quicker. But well, a couple of options. We could also expand all this, but notice that, right, this is going to take us forever to expand. We would have what? 2, 2, 5, 6 brackets to expand. Okay, so can't really do that. That's not an option. So we got to find a simplified expression for f of negative x from this factored form. So what we have to do is we got to plug in negative x for all of the x values, right, in all of these brackets here. And so here is where it's going to get super nuanced. So just be careful. Oh, and look, I'm already screwing up. This is 2. This is 2, right? So make sure you're getting all the details down here. Just be careful with your steps. What you want to do is we got to factor out a negative from all of these brackets because we can't have a negative x plus something, because then it's going to be hard to compare to the original function, because notice the original function, it has x plus 4, x minus 1, x plus 2, right? So what we're going to have to do is from this first bracket, we got to factor out a negative 1, but because there's this 2 here, we have to square. Basically, let me show you this on the side. If we got something like this, the process is basically we're taking out a negative 1. That changes to x minus 4. Within the bracket, we have this squared, and then we're distributing that exponent to the negative 1, and then the x minus 4, like that. Okay, so that's what's happening behind the scenes, and I'm kind of like skipping this step here in the main process just because then it's just going to get too hectic. All right, but that's basically what's happening. So I'm taking out a negative 1 from this bracket. I have to square it, and then I'm left with x minus 4, and then that's getting squared. Same thing here, taking out a negative 1. There's an exponent 2 here, so that's getting squared. What are we left with? X plus 1, right? If I take out a negative 1 from negative x minus 1, I'm left with x plus 1, and that's getting squared as well. From this bracket, taking out a negative 1, there's no other exponent here like 2, there's like an imaginary 1, so it's just negative 1 that comes out of that. That will become x minus 2, and I'm taking a negative 1 out of this, it becomes 2x plus 3, like that, right? All of the signs are changing. Okay, so just be super careful in this step. You have to factor out basically a negative 1 for all of these. Is just remember that if there's an exponent there, you got to take that negative 1 to that exponent. There was no exponents here. There was like an imaginary 1, so we're just taking negative 1 to the power of 1, right? Here there's an imaginary 1, negative 1 to the power of 1. Okay, so what's going on here? We got a negative 1. There's like this negative 1 here. Now, negative 1 squared, that's just positive 1. We got x minus 4 squared. Negative 1 squared, that's like positive 1. X plus 1 squared. And now notice we got this negative 1 here and this negative 1 here. I'm just going to multiply those right there. Kind of combine them together. That's going to be positive 1. Got x minus 2, 2x plus 3. And we just got to get rid of all of these 1s and negative 1s. So we'll have negative 1 times 1 times 1 times 1, which, because of this negative 1, it gives us a negative right there. And then we're just left with our factors. X plus 1 squared, x minus 2, 2x plus 3, like that. Okay, and this here, this final line, simplified polynomial, notice that that right there is basically our simplified, sorry, there should be a negative here. Okay, don't forget that. This is basically our simplified expression for f of negative x. This whole thing right here. And so now we could use this to compare to the original function. Does f of negative x, does this equal to this? No, it doesn't. Completely different intercepts, right? Here we have an intercept of 4. Here it's negative 4. Here it's negative 1, positive 1. Positive 2, negative 2. Negative 3 over 2, positive 3 over 2. So both of those are not the same, and so we know that this function is not even. Now, to check whether it's odd, we have to check, does negative, or f of negative x equal negative f of x? Well, thankfully, negative f of x is super easy. All we do is we multiply this whole thing by negative 1, and so all that does is it basically, whatever coefficient is in front here, this is factored, it just changes the sign of that coefficient. So this negative 1 here would basically change to like a positive 1. But then all of the factors would stay the same. So when it's expanded, you got to expand that negative 1 inside the entire function and then change all the signs. But if it's a factored form, you just multiply that negative 1 by the coefficient in front. So let me actually rewrite this fully just so you could have it as a reference. So I have a negative, and then I'm rewriting that entire original function as it originally was, right? This is the f of x inside this big bracket, and then we got the negative on the outside, and then it's just negative times negative, which is positive, right? So there's like an imaginary positive 1 out there, and then all these factors, they are staying the same, like that. Okay, so if this was, again, expanded, if it was an expanded polynomial, like in part A, you got to distribute that negative inside everything. But when it's factored like this, everything is multiplying, not adding or subtracting. Just multiply the negative 1 with whatever is in front there, right? So that is the expression for negative f of x. Is negative f of x equal to f of negative x? Well, no. Notice that the intercepts are totally different again. And so from there, comparing this to that, we know that this function is not odd. And so in part B, this function is neither as well. Yo, what's up? Quick little intermission here. Wanted to mention a few things quickly and we'll get right back into the question. First off, if you are getting value from this video, if you can please like the video and subscribe to my channel, it does help me out a lot. Number two, if you're watching this on YouTube, you can go to the description box and there is a link that will take you to my website, allthingsmathematics.com, where all my courses are organized so you can watch the videos in order, and I'd recommend doing so because lots of concepts carry over from one video to the next. Also, for lots of the courses, at the end of the chapters, you can find tests that you can practice with, and the tests have video solutions as well. Number three, if you feel like you need personalized help in tutoring, give me a shout. I currently tutor students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. You can text me. We can discuss availability and then we can book a session. My contact details are on my website. And lastly, feel free to forward the website to any of your friends who are also taking the course, who you feel can benefit from these videos as well. Hit me up on all my socials. It's All Things Mathematics for all of them. Back to the video we go. Now, the final one, part C, another factored polynomial. We got x minus 1 times x plus 3 times x plus 1 times 3x minus 9. Now, one thing I like to always do with the original function, which I didn't mention in parts A and B because we didn't really have to do anything there, is I like to make sure that everything is fully factored. And notice that with this 3x minus 9, I could take out a 3 from that bracket. So that's what I'm going to do. I'm going to take out a 3, put it in front. I'll have x minus 1, x plus 3, x plus 1, and then what are we left with there? If we take out a 3, we're left with x minus 3, like that. Now, you don't necessarily have to do that step, but personally, I like to do it. If it's a factored polynomial, I like to make sure that it's fully factored. So if there's any constants I could take out from any of the brackets, I like to do that and then put them in front. And so this is the f of x that I'm going to be using throughout the process here. So here you want to now find a simplified expression for f of negative, just like we did in the last one. So we would plug in negative x for all the x values. And you got to be super careful here. Got plus 3, negative x plus 1, and then we got negative x minus 3, like that. Right? And we can't just leave these as negative x's here because we have to be able to compare it to this original function that we have. Notice this original function, it just has x values in the factor, so we can't have these negative x's here. So what you want to do, actually, you know what? Let me create a little bit more room here. What you want to do is basically factor out a negative 1 from all of these brackets. So if I take out a negative 1, I'll have x plus 1. If I take out a negative 1 from this bracket, I would have x minus 3. If I have a negative 1 from this bracket, I'll have an x minus 1. And then if I take out a negative from this bracket, I'll have x plus 3, like that. And then let's simplify all these negative 1s. Now, how many of them are there? 1, 2, 3, 4. So it's like negative 1 to the power 4, which is going to be positive 1. So we would just end up with a 3 in the front. We'd have a positive 1 there as well. We don't have to write that. And then we'd have x plus 1, x minus 3, x minus 1, and then x plus 3, like that. Now, if there was 3 negative ones, it would be a negative 1 to the power of 3, and that would be a negative. We would attach it with this 3 here. So we'd have a negative 3 in front if there was an odd number of negative ones, but there's an even number of negative ones, so it would just stay as positive 3. And then this here is the simplified function for f of negative x. And if you look carefully, this function and this function f of x, they're actually the same, right? So we got the 3 in the front. Now this x minus 1, it changed into x plus 1, but notice that this x minus 1 here, we have another x minus 1 here. X plus 3, x plus 3, x plus 1, x plus 1, x minus 3, x minus 3, right? So even though the factors in those specific spots changed, the other factors changed as well, and then those other factors ended up being the same factors as the original function, right? So these two functions, they're exactly the same. So we know that f of negative x is equal to f of x, and therefore this function is even. All right, so with these kinds of questions where you're checking the symmetry of both expanded and factored polynomials, the process is a little different. The expanded ones, it's a lot easier, right? It's a less hectic algebraic process. When they're factored, it takes a little bit more effort, but nevertheless, this is the process that you go through. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.